Good. Thank you very much for this introduction, and good afternoon, everybody. In the next 20 minutes or so, you will hear about the two kind of general categories when we talk about service pricing. And we will also talk about the futures of on-demand rental cars, or let me be more precise, of what we perceive where the world is going in on-demand rental cars until the point in time when we have autonomous cars who can pick you up at any spot and have a legal framework for that. We'll also talk about the properties of the algorithm we implemented at our client and the data sources which are currently, so at this moment of time, used to price on-demand rental cars in a few cities in Germany. Now, we are not a rental car company, but we worked together with one. And as ETM Predictive, we help organizations which have an interest in machine learning to kind of explore, set up, and launch, as well as maintain projects just like the one we present today. When Jan and his co-founders started the predecessor company of ETM in 2002, they did a lot of financial security pricing. And I think it's fair to say that until this point in time, pricing is the strongest muscle that ETM has built. And this is also why the presentation today will be about the pricing topic. What I will also talk very briefly at the end of our presentation is soccer, so stay tuned. Maybe that's also of interest for you. So, going to pricing. When you think about pricing, and now you have to put on your economist glasses, pretty much most of the services we buy or order every day are cost-based. Let me give you an example. If your bathroom needs fixing, you can get quotes from a few companies in town, and what they use to price their services, the fixing of the bathroom, is the input factors. So that means the time they take to do the job and the material, and they add the margin, and voila, what you get is the price. There's very little differentiation between the companies, and they should more or less quote similar prices, and it doesn't really matter if you kind of get the quote in March or maybe at some other month, and it doesn't matter if you live in the north part of town or the southern part of town. More or less, sure, there are exceptions and people get ripped off, but generally I think the concept holds. Now, there's this other kind of strange animal that, for the lack of a better term, is called value-based pricing. And that definition, which we'll follow, is at least debatable, I'd say. And it goes like, if there's somebody willing to pay X amount of dollars for a service, then it has at least X value for that service. And I'm sure we all kind of know of these services and accept, and when an example it becomes clear, when you book a night in a hotel in Mallorca on a Saturday in summertime, well, sure, that's going to be more expensive than the same room on a Wednesday in winter. Nothing really new, right? It's supply, demand, you know that. Now, how does that translate to on-demand rental cars? So, maybe a quick side note so we're all on the same page. There are on-demand rental cars placed all over a few cities in Germany, and they can be opened up by a phone using an app or a card similar to what you maybe know from the Swiss Pass. And the technology used to start them and to locate them is pretty similar to what you know from the e-scooters, the e-trottinettes, which are also here in Switzerland, and the ones where you're passed by a 14-year-old going at light speed on the walking zone, right? You know what I'm talking about. But yeah, these cars which are placed in these cities, they are not that huge, to be honest, at least in the past, and that's because of the business model, which was the underlying in the past. Some of the cars are not picked up that often. And let me illustrate with an example why this is the case. What you see here in the picture is two cars, and they are placed around a movie theater. Let's say the movie's over, people want to go home, and there's a lot of demand now for mobility. The one car that you see in the upper left corner is close by, so a person books it right away. Still on? Okay. I didn't do anything. All right, let's assume you all hear me. So the first car gets booked right away because it's so close by, whereas the second car, which is further away, and people might think, well, it's too far to even walk there. Maybe there are other alternatives, maybe an Uber and tram, just taking the train. So it's not booked at this time because people make this comparison. What is the next best alternative? And I'm sure they find something better. So that car stands there for a while. Now, here only one car gets booked, so the total revenue is 33 cents times the amount of time it's booked. So maybe not so good of a business model. What would be a better alternative? Well, let's look at dynamic pricing. Here, the prices have changed. One car being now pretty expensive at 55 cents, and the other one dropped to 25 cents. Well, for that first car, which is close by, there's still going to be one person which really needs to get home very quickly and is willing to pay that much. And you only need one because you only have one car, right? And then for the other car, which is further away, it's still more expensive than the variable cost for the operator for that car. But now, at least in this simplified example, you do see that a person would actually walk over there and tap the car. So in this case, with the dynamic pricing, revenue goes up to 80 cents and margin goes up as well. Now, the million-dollar question arises, though, well, how do you do? And maybe, first of all, the question, avoiding bad reputation for high prices, but that's not what we're going to talk about today. But the big question arises, how do you do this pricing? And for that, I'd like to hand over to Jan.
Thanks, Daniel. Yeah, let's dig a little bit deeper into the technical part of the pricing solution. When people think about dynamic pricing, they often think about that iPhone users have to pay more than Android users, something like that. This is not what we are talking about. So every customer, in our solution, every customer has to pay the same price for the same product at the same time. So no personal features are used in this in the pricing solution. So then you might wonder, what are the drivers of the? Maybe I should take the next slide. I think at least that was the plan. Okay. So you may ask, what are the drivers of the prices of our pricing solution? And this is, as Daniel already told you, I think, it's demand for the product, the availability of the product, and the price elasticity. And you may think that this is a quite old-fashioned or traditional approach, but I can tell you from a data scientist's perspective, it's quite exciting to do it in that way. In the end, our pricing solution is something like an optimization function, optimization problem. Therefore, we have to make some assumptions and some constraints. These are, for example, that two cars close to each other have the same price at the same time. All clients see the same price at the same time for the same car, for the same product. Pricing is cost per minute. There is an upper and lower bound for the price. And a reasonable reference or base price have to be specified. This is something like the price of competitors or an average price, something like that. And this is not a free parameter in the system. I told you that that demand and availability drives the price. More precise, it's a demand forecast. what drives the price, because the price has to be shown to the customer before the customer books the car. So you do not know the real demand in this situation, so it has to be predicted as well as the availability. It's a little bit different with elasticity. There it's more an inclusive model, more static one, but that later. So we have the issue to predict demand, and therefore we set up a quite traditional machine learning approach. And the same is true for the availability. So these are very similar models, except the target. So in machine learning speech, only the target is different. And therefore, we take features like geospatial information, the own history of demand and availability, so how many users booked yesterday and that stuff. We take something like weekday, hour, is school day or not, holidays, and all that stuff. And an interesting point is that the most important features in this approach, at least for demand, is the own history, right? So the features derive from the time series of the own history. And in general, so our experience is that this is often the case, that the own history contains a lot of information, and this is the most important feature. And it's more important, for example, like the geospatial information, like we have something like a number of restaurants in this area near the car, number of tourist attractions, number of train stations, and all that stuff. But this is not so important because that does not change. So this is quite static in the model, and the time series does change all the time. So the dynamics in the business are better represented in such time series variables. Then price elasticity is, our definition of price elasticity is the change in demand caused by the change in price. And to measure this price elasticity, it's much harder than you might think at the beginning. I give you an example. You implement a reasonable pricing strategy in one city in car sharing. The city center, you charge high prices. In the outskirts of the city, you charge lower prices. You do that, collect the data, and after a while, you try to measure price elasticity. And what you find out is, if the price is high, then the demand is high, and if the price is low, then the demand is low. This is counterintuitive and also wrong, because the reason for the high demand in the city center is not the high price, as you can imagine. So it's the don't know, more people are in the city center, higher traffic density, also such natural drivers of demand. So if you would reduce the price in the city center, the demand would be even higher. And to measure elasticity, the solution is that we have to bring in a change in the price and also a change in the demand, which is uncorrelated to the natural demand drivers. And this we can do by adding a random component on the price. So just adding on you calculate the price and then adding on top a random component on the price, which can be negative or positive. The distribution can be different, but a random component on the price leads to a change in the demand in a similar way, and with that way you can measure price elasticity. So imagine we have now we have the demand models, availability models, also the elasticity. And then we ask how to pull out a price of this. And this is done by, or the easiest way to do that is by optimization, by implementing an optimization problem and solve it. And here we see in this chart a orange line like this, and this is the demand curve. It's demand over price. Okay, so this already includes the price elasticity. So higher price here leads to lower demand, then lower price, higher demand. If we multiply the price with the demand, we get revenue. This is the blue curve. And if we want to maximize, and this is the purpose of that, if we want to optimize our price, what could be the function we optimize? And as I said it already, it could be revenue, for example. So let's maximize revenue. This is the point with the maximum revenue by varying the price. This is, I cannot see it from here, but it's roughly 20 Rappen, right? So in this example. It's not a real-world example, it's just for illustration. In real world, we unfortunately do not have such beautiful maximum and that stuff. Okay, so it's 20 Rappen here in this example. Okay, charging 20 Rappen isn't, or is, if you know that 40 Rappen in this example are the variable cost of the product, then it might only be a good idea to charge 20 Rappen if you have a huge pile of cash like Uber, for example, because in this case, you gain revenue, you gain market share, but you make losses. So that's not the best idea for all companies. So another approach would be maximize margin. Margin is defined as price minus cost multiplied by demand. This is shown in the green curve. So maximizing margin leads to a price here of 50 Rappen, I think. This is a relatively high price, which leads to a high margin. That's why we did it. But on the other hand, you probably lose market share and revenue when charging that price. So what about we make a mixture of both? So we optimize revenue and margin at the same time. What I did is adding these two terms, give them a weight of 50%, and this is shown in the brown curve. Optimizing or maximizing this function leads to about 40 Rappen, which is the compromise of optimizing revenue and margin at the same time. The weights of 50-50, you can choose what you want, right? And also other terms are possible, no problem. Keep in mind that this optimization is repeated very often. So every hour or every time interval, every area in the city has a different price optimization function, and it's solved all the time. So with this approach, you get a quite dynamic pricing scheme. There is another simplification, what I did here, is that we optimize only one time step and one area, or one car, one area. Better is to optimize several areas or the entire city and to take into account more than this time step in the future. That is a better solution. The issue then is that it cannot be formulated, or in general, it cannot be formulated as an optimization problem which can be solved analytically, something like that. So this part can be solved by using deep reinforcement learning, for example. So starting with such machine learning approaches and apply that to real-world problems, you probably know it's quite tough at the beginning. So at the beginning, we only had very little data. So the results were not that good for sure. Nobody expected that they were good. So just testing. Now roughly so about half a year later, with about half a year of data, the system works quite good, and we are comparably good, maybe a little bit better than the pricing what the clients, the experts, the pricing experts manually do. But more important is that the solution we have is fully automatic and it scales beautifully with the growth of the business, right? So adding new cities, adding more cars, and all that stuff is minimal effort to implement this, and the maintenance effort of such a solution is comparably small against the effort of implementing such a pricing strategy manual by human experts. Thanks.
Good. Wrapping up. So there are plenty other use cases compared to the one we just introduced. General mobility and hospitality are kind of big areas where this works. But I also think anything related to leisure industry, ski passes, for example. The city of Andermatt in St. Moritz last year started something similar related to dynamic pricing for the ski passes, other things like tours, parks, and so on. So one takeaway, though, I want to summarize again. The beauty of dynamic pricing is that it allows to optimize two things at the same time, margin and revenue. And if you think of kind of what the traditional understanding of price elasticity is, well, it's kind of unique. It hasn't been around in this form. I'd like to close here for pricing, and quickly I want to show you something else. Friday afternoon, so soccer. We built this kind of fun pet project. It's a soccer game outcome prediction engine, and I'd like you all to take out your phone and use the camera app to scan this QR code. So please do. And it connects you to our Twitter account where you can follow, and when there is a game on, you get our prediction results, which are quite good. Evaluate for your own. And you will see, as this is the picture that we put on the Twitter feed, and you see the prediction for the winning team in the gray bar, and then in white is the draw probability. And if you're into sports betting, now is the time where you really want to pay attention and think of us if you do make some money on this. The Twitter handle is @ETMPred, P-R-E-D, if you want to write this down. Or I don't know if this works on the screen. I hope it does. We'll see if we have some more followers. Okay. Yeah, on a more serious note, if you do care about dynamic pricing, we will be around. Please see us if you want to talk other use cases. We appreciate your attendance. Thank you so much, and looking forward to your questions.